Uh, yeah, hello friends. So please let me know whoever have joined and am I audible or not. Yeah, so whoever have joined guys, you can ping in the chat. So today we will start with the decorator concept. Okay. So let's me create a folder. So please let me know friends if everyone is able to hear me or not, or if anyone has any issue. Okay. So today we will see what are decorators and what is the use case of decorators, and before that we will also see some of the concepts for the decorators. So let's get started. Okay, so before going to the decorator concept, there are few concepts that you need to know. So what are those? So those are basically, number one is closure concept. So what is closure and what is the use case? Then in Python, the functions are known as the first class citizen. So what are those? You need to know. And then you need to know higher order functions. So what are higher order functions and what are the use case? So these things you need to know the basic concept. After that, you will know like how to use the decorator and what is the use case. So let's start one by one. So before going forward, so anyone in this chat know like what is closure or any concept? I'll just teach you here also. So what is closure? So closure is basically an inner function that remembers the variable from its enclosing scope even after the outer function has finished executing. So what does this mean? So let's say basically what will happen. Suppose, let me create one file. Closure.py. Okay, let's create a function. Let's say def test. Okay, and here I am taking one argument x. Here let me take another argument y. Let me print y. Okay, now when I am invoking this test function, what will happen basically, and I am passing some value. So this test function will get invoked. These variables y equal to 10, this gets created, this x is also getting created inside this test scope, and when the function execution is done, so all these things will get deleted from the memory scope. Okay, so there will be no existence of this variable x and this variable y in the memory scope. But what is closure? So in closure, what does this means is that we will have a function. Okay, so even, and we'll have some inner function. Okay, So this is an outer function. This is the outer function. And this is the inner function. This is the inner function. So even if the outer function execution is done, let's say in outer function we have some variable x equal to 10, and we are using that, trying to print that value inside this inner function. So even if the outer function execution is done and the memory scope is deleted, still this inner function can access this x from the outer scope, from the outer function. This is the core concept of closure. Okay, so we will see this concept. So for closure, what are the things you need to know? So there are three requirements for closure. So there are three requirements. So what are those? Number one is there must be a nested function. So there must be a nested function. This is the first requirement for closure. That means a function, there will be an outer function and there will be one inner function. This is the first requirement. Then second, innermost function must refer to a variable from outer function. That means must refer any variable from outermost function. That means, see, this innermost function is referring to one variable x, right? This x variable is from the outer function. So this is the concept. The innermost function must refer any variable from the outermost function. So here basically, see, this x is basically referring to the outermost function. This is the second requirement. And what is the third requirement? That outermost function must return inner function. So these are the three conditions that needs to be met for a closure to work. So let's get different. What is the concept of this? So let me create one function. Def, let's say outer function. And let's say here I am taking one variable x. And then, so what are the requirement, friends? Let's go one by one. So there should be one nested function, right? So this is one outer function, and nested function means there should be an inner function. Let's say def inner function. Okay, let's for now. So this is the first condition met, that we should have a nested function. The first condition has met. Now what is the second condition? Innermost function must refer any variable from the outermost function. So this is the innermost function. Okay, so here there should be some operation that will involve the outermost function variable. So see, in the outermost function we have this x variable, right? Or you can define any variable here also. Let's say y equal to 10, anything. So it should refer any of these variable. Okay, so let me remove for this now. So here, let's say here I am also taking another variable, let's say y, and here what I am doing, I am just returning x plus y. I am just summing up both the function. Okay, so this is done. Now the second condition is also done, means that innermost function must refer to any variable from outermost function. Okay, that is basically this variable x. Now what is the final condition that needs to be met? Is that outermost function must return inner function. Okay, so this is the outermost function. So here I am returning the inner function. Now it had made all the three conditions. Returning inner function. Okay, now we can tell this is a closure. Okay, now how to use the closure? So let's say first how to invoke the closure. First you need to call the outer function. So let's say here let me take f equal to outer function. Here I am passing the value of 10. Okay, so what is happening, friend? If I am invoking this outer function, so basically what it should happen, the outer function. So this is basically returning the inner function. That means f is now containing the reference of inner function, right? That means the execution is completed. That means this variable should get destroyed, right? Because once the function execution is done, all the variable inside this function will get destroyed. But here it will not be the case. Why? Because this is the concept of closure. Even after the outermost function get destroyed, the inner function can still access the outer function variable. Okay, so let's see. For example, here I have passed 10, so now x is containing 10. Now here, now f, and what is containing f? Since it's returning the inner function, that means f now pointing to this inner function. Now let's say I wanted to print this inner function. Okay friends, so what I will do, so here print f, and here I am passing 5. Let's say what I will get. Let me press. Let's say cd decorators. Let's run Python closure.py. So see, we are getting the output as 15. So that means how this innermost function x is still it able to access this x variable, because the outermost function has already been executed here, right? That means it should get destroyed. Then what's happening? So here the concept is like this, friend. So whenever there is an outermost function and an inner function, and if inner function is referring to any variable from the outermost function, so it's basically creating another memory space. Okay, so it is creating, let me, so basically it's creating another memory space, and in the memory space all the variables in this inner function which are from the outer function are getting stored here one by one. Let's say which variable we are using from the outer function in the inner function, that is the x variable, right? So that means in one scope the variable x is now stored here along with the value. Okay, so x equal to 10. So here x means, that means the value of 10 is stored here. Okay, so suppose if here we have another variable, let's say y equal to 30, and if we are printing y here also, that means the inner function is referring to the outer function variable, that means that will also get stored here. That is y, and the value will be 30. So in this way this variables is stored here. So even if this outer function, let's say this outer function is destroyed now, okay, this everything is destroyed, then how it's going to refer this x and y since the outer function is destroyed? So basically it's going to check the closure. So this x will now check the closure, and from the closure it will fetch the value. This is the concept of closure. This is the same concept as in the JavaScript, friend. Okay, so how to debug? So this is the way, even if the outermost function that is executed, still since we are using this variable x in the innermost function, this x is getting stored in the closure. Now how to debug that? So for that you can check, you can write print. So this f is the function, right, which is calling the outermost function. You can write f dot underscore underscore closure. Okay, so this is a magic variable. Here you can see, let me write, see, this is the print. So basically this is the space in which the closure and the variable is stored in this memory location. Okay, that means here basically a memory location is allocated for this whole closure. This is the memory location of this closure, and this is like a list. Okay, this will act like a list. So suppose in this memory location, if we try to access the 0 position, that means it's going to access the x. If we try to access the first index, that means it's going to access the y. So this is done internally by Python, but let me show you that also. So here if I try to access dot 0, sorry. So this is an array of 0 and then the cell contents. Okay. So what is this? This cell contents. So cell contents are basically, these are the cell contents. This X is a cell content, Y is a cell content. From here we can get the access of this variable. So, so this is basically a typing error. For now, let me type. See, this is the 10, right? So this 10 is basically nothing. We are assigning this 10 value to this X, and that is getting stored in the closure memory. This is the whole concept of closure, friend. So any issue in this concept, please let me know. Please ping in the chat if anyone has any issue in this concept. Okay. So now this is the one concept that is need for decorator. Now we are moving to the next concept, that is the first class. So let me create first class.py. So what is this means? So basically in Python, functions are first class citizen. Means that we can treat function like any other object, okay, like integer, string, list, etc. Like any other object, we can also treat function in the same way. That means, so here are the few points. Like we can assign a function to a variable. Okay, like how we assign a object to a variable, right? Or any data type. Let's say x equal to 10, right? We are assigning this value 10 to a variable x, right? In the same way, we can assign function also. Like how? If I, let's say, def greet and let's say print hello. So this function, we can treat this as a variable, okay, or a object. So here I can say y equal to greet. Okay, so here we just need to write the name of the function, that's it. And then y is now pointing to this function. Now we can write y. We can invoke the y itself. Let me write Python. See, it's printing the hello, right? Now y is pointing to this function greet. So this is the first rule, that we can assign a function to a variable. Now second, we can pass a function like an argument. Okay, like how we pass a variable to an argument, right? In the same way, we can pass a function as an argument. How? Let's say I write def let's say apply, okay, and here it will take a function. So guys, just let me show you one thing. Let's say, what does this mean? Let's say if you create a function, okay, let's say you have created an add function. That means let's say you have created an add function, okay, this is an add function, and here you have written all the function logic. So what does this means? So basically this means it get allocated to some memory location, okay. This add function have some memory location, let's say 5005. So when I say invoke this add function, that means it's telling Python that go to this memory location. That means internally how it's getting interpreted, let's say, is that go to this 5005 location and invoke this function, okay. So think this like this. So it will go to this memory location, invoke the function, and whatever the code inside it will get executed. Now if I do like this, y equal to add. So what does this means? This means we are creating a new memory space y. Okay, this is a new memory space y. Let's say this is in memory space 6006. But what is the value it containing? It's containing add. That means it's containing the memory location of this addition function. So that means it's containing the memory location 5005. Okay. So when we invoke like this y, so first it will check what is the value here. So this get replaced like this. So the value of y is 5005, right? The same thing, 5005, and invoke that. So see, we are coming to the same thing. It is the same thing like this. So assigning a function to a variable means we are assigning the memory location of that function. Okay, that is the reason we can invoke a function by the variable that is being assigned to the function. So this is the concept, friend. So what is this? Let's say here I will invoke the function. So how to call this? Let me create a function. Let's say, so I have already a function, right? Greet. I have already one function greet. So what I will do? I will just do apply, and here I will pass the function name greet, like that also, or you can pass the variable y also, anything. In this way, this greet function will come in this function and it will get executed. This is a passing a function as argument. It's printing, still printing hello, because this apply function is taking this greet function. That means the memory location of this greet function, and this is executing in that memory location. This is the second condition. So what is the third condition, friend? Third condition is basically we can return a function from another function. So returning a function from another function is nothing. You can tell this it's a closure also, okay? Because in closure we have one function and we are returning this inner function, right? The same thing. This is the logic for this third one. We can return a function from another function. This is nothing. You can tell this as closure. The concept of closure. So these are the mainly the three rules, friend, for a first class citizen. That means we are treating Python function as normal object. Okay, so this is nothing any special. It's treating like a normal object, like we treat integer, string, anything, right? So we can pass, see, we can assign a value, integer value to a variable. The same way we can assign a function to a variable. We can pass integer or list or anything as an argument to a function. We can pass it directly a whole function as an argument, and also we can return a function as argument. So this is the concept of first class citizen. So any issue, friend, till here, please let me know in the comment section, because these are the very important concept you need to know before moving to the decorators. So let me know, friend, if you have any issue here. Okay, if no, can I move forward? Okay. So let's move forward then, friend. Okay. Now there is another concept, that is the higher order function, right? As I told. So higher order function is nothing, friend. So higher order function means taking a function as argument, okay, and return a function. So that means this 0.2 and 0.3. So this is known as a higher order function. Okay, like I will, let me tell you. So let me create a file, higher order function. Okay, so what does this means? It means, so what I told, That means, let me write it here. So it will take a function as argument. Okay, and the second point is it can return a function, okay, from this function. So a function that is taking a function as argument and it's also returning a function. This is known as higher order function. So let me give you an example. Let's say we have a function, let's say test, let's say. So what is the first? It will take a function as argument, right? So I'll take a function. Now it will return a function. So to return a function, that means we need to create an inner function. The same concept of closure. Let me repeat, wrapper. Okay. So now what is my concept? Suppose this function is nothing. First, let me create the function. So let's say def greet. It is like returning hi. Okay, string. So what is my concept, friend? What this wrapper function will do? It will call this function. So basically greet. Whatever the function will return, I will just convert that to upper letter. Okay, in the uppercase letter. That means first I will invoke the function. So let's say this function will return some string value. So whatever the function is returning, I just wanted to change that to uppercase. That's it. Okay, and I wanted to return that. Done. So this is the concept. This is the inner function working. Now what is the second point I need to write? It should return a function, right? So that means I am returning this wrapper. So now this is an higher order function. Okay. Now how to call this function? Let's say response. So I will call this test function, and inside the test function I need to pass the argument as function, right? I need to pass any function as argument. So this is the function greet. I'll pass the name. That means the memory location. So let's say this greet is in memory location 3005. So this means I am passing this 3005 into this function. So now whatever the in 3005 the function is there, it will execute that. It will return the result, and that result I am changing it to the uppercase. That's it. So this is the concept of higher order function. So let's test it. Python. Okay, so I need to print that. Sorry, I need to print this response. Okay, see now what it's giving? It's giving me the greet. That means it's returning this wrapper, right? That means it's returning this inner function. That's why this response is now containing what is the memory location of that inner function. To print that, what I need to do? I need to invoke that. Since it's a function, see, it's a function, I need to invoke that. See, now I am getting the high in the uppercase. Okay, this is the concept of a higher order function. Or you can also write like this also. Okay, you can invoke this and you are invoking the both function, but sometimes this will get you confused. So this is the way you can write. So here, so this higher order function will use this concept in the decorator. Okay. So basically, this is the concept we are going to use in decorator. So up to here, friend, any issue? Okay, X is saying no. Okay, great. Now we are moving into the decorator section. Okay. So what is decorator basically? So for that, let me give you an analogy. Okay. Let's say you are a person. Okay. let's say you are a person and you should go to the office to work, right? So, and this is, let's say this is your cabinet. So how things work, basically you go to the cabinet, you works, and then you log off, right? And you go to come to your home. So what is your primary functionality? Let's say this is a user, let's say the username is John, okay, and let's say John works in a travel agency. So what is the primary function of a John? So the primary function of John is to, let's say, book tickets, okay, or hotels. This is his primary task, right? This is the primary task of John. But in office, most of the case, what will happen? Before going to the cabinet, John need to first swipe his ID card, right? So he need to swipe his ID card to enter to the office, right? So that it get logged. Like when John is entering to the office, it will get logged there. The same case when John's task is complete, let's say at 6 p.m. his whole task is complete. Now he wants to go to home. Then what he need to do again? He again need to swipe, right? He again need to swipe and go out. So this is basically the whole flow. So for this swipe action, let me ask you guys. So for this swipe action, do you think is there any change in John's working principle, or is there any change in John routine in his work? What do you think? Okay, take X is showing no change. Any other guys? What do you think? Like the John needs to swipe, right? So after swiping, he goes to his cabinet, he will work, and then he will swipe out and go. So what do you think? Because of this swiping action, will there be any change in John actions or John's job? Please let me know in the comment section, guys. Okay, the thing is, no, there will be no change, right? Because if you think this of your own perspective, we go to office, we swipe, but we need to do our daily task, right? We need to fix the bugs, we need to build new features, everything. But for this swiping action, there is no change in my daily routine. So why we are doing swiping? To track, like the office is tracking when we are logged in, when we are logging out. For the tracking purpose, we are doing the swiping. So this is basically the decorator, nothing else. So the task that John is performing is the real function. This is the real function. Okay, and whatever the swiping we are doing, like before our real function, so this is before, right? This is before and this is after. So before and after the real function, if we wanted to do some task, that we can do with the help of a decorator. This is a decorator. This is a decorator. Okay, this we can do with the help of a decorator. So what is a decorator then, friend? So decorator is nothing, basically it's going to give us some extra functionality. Okay, so decorator is basically a design pattern that allow us to add extra functionality on an existing function, and but without modifying the real function. Okay, here we are not modifying the real function, we are adding some extra functionality to the real function. This is the concept of whole decorator. So let's see how to create a decorator. So first let's take an example, like why we need a decorator. Let's say here I am creating decorator.py. Let's say here I am calling dev add to variable. First I am printing operation started, then what I am doing, I am then doing sum equal to a plus b. Okay, print sum, and then I am doing print operation ended. Okay, now again let's say we have another function def subtract. Okay, let me copy the same thing. So it is also taking two parameters, the same thing. So first it will print operation started, instead of summation it will be subtract, and then we are doing operation ended. So if you see here friend, these are the repeated tasks, right? Repeated lines. Operation started, operation ended, operation started, operation ended. So what we can do for this? Any way that we should not repeat this code? So what do you think? What is the way? So one way is that you can create a utility function and call that, right? Let's say you will create some utility function, def op started, and then you will say print operation started. Okay, and you can call this op started here, but this is not a good solution. Still you are calling the op started every time, right? So this is not an ideal solution. So for this we need a decorator, because what I tell, see, this is our real task, to do the operation and to print that result. But this, we can say, this is before the starting of a task and this is after ending the task, right? So this is before the office period, like when we are swiping in to the office, and this is the section when we are swiping out of the office, right? So we can move this logic to a decorator. Then how to create a decorator? Let's do that. To create a decorator, what we need, right? So we need to create first a higher order function. That means def logger. Okay, this is the name of the decorator. And in higher order function, what I have told, it should take a function as argument and it should return a function. And how we can able to do that? Because in Python, function is treated as first class citizen. That is the why we are able to do this. So here we are taking function as an argument. Okay, and it should also return a function. Now, in higher order function, what I have told, that it should have a wrapper function, right? It should have an inner function. That is the concept of closure. So here we'll write a wrapper function. So what does this wrapper function will do? So what is the use case of this wrapper function? See, whatever may be the task, if this is add, subtract, let's say add will have 3 parameters. Okay. So this wrapper function will take all the parameters that are needed for this function to execute. Okay. So it will take all those parameters. But how to know how many parameters are needed? Because it is taking 3 parameters, it is taking 2 parameters. So what do you think, friends? So is there any way to know how many parameters a function is needed? Or how to take a variable length argument or parameter? Yeah, so that's correct. That is star args. So here we write star args. Okay. Now second point, user can also send keyword argument, right? Let's say suppose if user is sending like this, b equal to 20, c equal to 40, a equal to 10, like this also. Then we need to also handle this scenario, right? If user send multiple keyword argument, then is how can we accept variable length of keyword argument? Yeah, correct. That is using star kwargs. This is the way basically we are going to accept any argument or any keyword argument. Okay, because we don't know whatever the function we are going to call, either it will contain keyword argument or normal argument, how many numbers, we don't know, right? So we need to handle both the case. So this is also done. Now what we'll do, so here basically we'll first write, we'll call the function, that is this function. Okay, we are calling the function here, and let's say we are going to store that result here. So this task, so this is the core function, right? So operation started, let's move it before the function. So this is like swiping in, and this operation ended, let's move this after the function. Okay, and after this, let's say you can write print result in decorator, let's say. Now this is done. So this wrapper function, it's calling the actual function. As I told friend, decorator will never change the functionality of a real function. The same way concept, right? This swiping in and swiping out is not going to change whatever the John's everyday work. It's just going to add some functionality, extra functionality. The same thing, it's adding some extra functionality, but it's not going to change the real functionality, the main logic of the real function. So this is done. Then what is the concept of the higher order function? We need to return the function. So this is the point. It should return a function, or this is also the concept of closure. You can say we need to return the innermost function, that is this wrapper. Done. So this is basically a decorator. Now how to use this decorator? That is very simple. So let me remove the print also. Let me return it from there. So how to call this decorator? Then just we need to write @ and then the decorator name, that is logger. That's it. Let me comment this one now. Now let me call this add, like this one. Let me write Python decorator.py. Okay, so add missing 3 required position. Okay, now what is the issue, friends? See, we are taking this argument. Now what it's telling? Add missing 3 required positional argument, right? A, B, C. So here see, so this logger is taking add as a function, right? And we are calling that. But are we passing any argument there? No, right? Because we are not passing any argument. So here, just pass that. We need to pass args star kw args. That's it. Okay, whatever we are receiving as an argument or keyword argument, just pass that. Now see, operation started, this is printed, then the actual function call happened, that is the add function. Then it is returning the sum, and then we are printing the result, right? Result in decorator 70, and then the operation ended. Same thing we can do for this subtraction also. So we are doing the logger. Now I'll just write sub, let's say 20, 5. The operation started, then result in decorator 5, we are subtracting, and then operation ended. So see, we are reusing the logic before and after the real function execution, right? So let me know, friends, if any issue in this concept or not. Yeah, thanks, Eric. So anyone else, guys, any issue with this concept, let me know. Then I will again explain this one. Okay, if there is no issue, then let me go forward. But if any issue, just ping in the chat. Okay. Now let's execute this one itself, like whatever we are doing here, right? That the real function. So let's say, for example, what does the swiping does? So it tracks, right, how much time we are doing our work in office, right? So let's create a timer function, that how much time it's taking. So let me comment this thing, whole thing. So what we need to do? Okay, before this, let me tell you another concept, friend. That is also important. So every function, okay, contains some metadata about it. Okay, so what is that? Let's see. For example, let me remove that. Let me remove this one also. If I write print add, okay, and then what is the metadata, and let's say what is the name of this function. See, it's basically telling what is the name of the function, right? Add. Okay, it's giving us some information. But if we add this logger, and let's now try to check the name. Now see what is happening. What is the name coming now? Wrapper. But is the function name is wrapper? It's add, right? But why do you think, guys, it's coming as wrapper? So what do you think, guys? You can tell whatever you're thinking. Why the name is coming as wrapper here then? Any guess? Anyone? Because of HOA, yeah, you can say, but it's not exactly because of that. So what is happening here? So whenever we are using this decorator, this add function is going to wrap, getting inside this wrapper function, right? So because inside this wrapper function, this all thing is getting executed. So that is the reason this, instead of add function, this result everything is under this logger function as getting executed inside this wrapper function. So this name, it's taking the name of this function, inner function. So you are right, okay, that it is because of HA. Yeah, so when that is correct, we are calling that function inside the wrapper. Because of that, it is the name is pointing to this wrapper function. Then this is not a correct one, right? Then this will give us a wrong information. Then what we should do? So for that, to preserve the function, like this function metadata, like the name and other metadata, so there is a option. So that is basically, just a second. Yeah. So there is a func tool library available. Okay. From there is a option available as wraps. So what does this wraps will do? This wraps will basically preserve the metadata of the original function. Okay. So where we are calling this inside this wrapper, right? So before this inner function here, like what I will do, this is also decorator wraps, and I will pass the function. Okay. So that please preserve the metadata of this function, the name, the doc string, everything. Please preserve that. Don't override that metadata with this inner function. That is the reason we write wraps. Okay. So this will not change anything regarding the functionality, but we do this because to save the metadata of this function. Now if I write, see, we are getting the add now because we are saving the metadata of this function add with the help of this wraps. So it's very important, friend, you should always use this wraps decorator. Okay, this is the point I wanted to show. Now let's go to the next section. Okay, so any issue till now? So any issue, guys, just let me know. Okay, so now let's go to the next function that I have already told you, right? To check how much time it took. Okay, so let me comment this section. Now we are going to create a timer function. Okay, so what are the steps to create that? The same way. Okay, before that, let me give you some of the rules. Okay, so what rule you should follow? The first rule is the decorated function can have any parameter. Okay, decorated function can have any parameter. What does this means? This means, see, decorated function, right? It can have any parameter ABC. Okay, or it in the subtraction case, what we have seen, it has two parameter, right? A, B. So it can have any parameter. We need to handle that. Then second point, wrapper must mirror or capture all parameters. Must capture all parameters. How we are doing that? How we are capturing all parameter? With the help of this star args and star KW args. Okay, using this we are capturing the whole parameters. So this is very important. Then the third point, the decorated function params must be passed through the wrapper. Okay, that means the decorated function param must be passed through wrapper. What does this mean, friends? Decorated function param must be passed through wrapper. See, this is the decorated function, right? Add. So all these parameters, from where we are passing the parameters? From the wrapper function. Okay, so all the function parameter must be passed from this wrapper function. So this is the third point you need to know. Okay, so many stealing. Can you show one example of parameterized decorator? Yeah, so mean after this example I will show you the parameterized decorator, and that is the most use case. Okay, most of the use case will be that one. I'll show you one real-time example also. Okay, so this is the third point you need to know. Okay, another point, friend, don't override argument. Okay, so that means don't pass like this arguments at this function. Since this is addition function, you can pass 10, 20, 30. Don't do like that. Okay, because this will be reusable section, right? So always pass this args and KW args. Now another concept is that always try to maintain type hinting. Okay, so you can give the type hinting. So here I'm not doing the type hinting because I will show you type hinting and also the pydantic in the next class or later class. So for now I am ignoring that. When I will do the type hinting, I will show you what that. So I will show you one decorator example with type hinting. But these 3 points you should always follow. So let's create another decorator with this rule itself. So this rule, we will create a decorated function. So now what is the point, like what is our requirement now? So basically my requirement is now is that it's a we need to define a decorator that is time, okay, or let's say timer, anything you can say, that will measure the amount of time taken by a function to execute. Okay, that means I wanted to create a decorator that will check, like suppose this addition function, how much time it's taking, this addition function, these things. Okay, I wanted to check that, how to do that. So let's create that. So we'll follow these rules, same rules. So first let me create the decorator. So for the decorator, friends, always remember the rule of closure and higher order function. That's it. Mostly the closure. So in closure, what you will have? You will have an outer function, you will have an inner function, and you need to return the inner function. Okay, and the inner function will use some of the variable from the outer function. See here, this inner function is using this func, right? The parameter from the outer function. This is the concept of closure. And what concept of higher order function? See, in closure, what will happen? The parameter can be of any type. Okay, it can be of type integer, number, anything. But as higher order function, the parameter will be a function as an argument. Okay, and this is the concept of higher order function. We need to maintain that the argument we should pass a function only. So using this concept, let's create this. So first we'll create a higher order function or a closure, that is def, let's say timer. So what it will accept? It should accept a function, right? The same concept. Now it should have an inner function, let's say def wrapper pass for now. And what is the next concept of a higher order function or a closure? That it should return a function. So I am returning this inner function, def wrapper. This is done now. Now what are the other things we need to use? First of all, that we need to preserve the metadata, right, of the function. So just write that. Here we are just preserving the metadata of the actual function. Now here we will write the logic. So what is the logic? So let's say here I will call the real function. But as I told Fred, whatever the function we are going to execute, that can have any number of arguments. It can have any number of argument, it can have any number of keyword argument. So how to pass that? For that we need the second point. Wrapper must capture all parameters. So in wrapper we must capture all the parameters. That means we should capture args and kwargs. Okay, and what is the third point? Decorated function param must be passed through wrapper. So this function, this parameter will be passed via these wrappers, right? So whatever the argument and keyword argument we are getting, we need to pass that from here. So this is done. So we'll store the result, let's say in res. Now before the execution of the function, let's say this is the job, this is the real function of John. So but before the real function, John need to swipe, right? So that the time get logged when at what time he is starting his office. So let's do this. Let's do start. So for time, what we need a time. So I will import time, this module. So here I will do time dot. So there is two alternate options. We can also use prep counter or you can directly use time. So for now I am using this time option. And then in the end I am also going to write time dot time. Okay. Now we have the starting time and we have the ending time. So how to get the exact time? So we can write print, let's say string timer took then end minus start. Okay, and let's say we want up to 2 up floating point. Okay, second. Okay, this is the time it took. So now let's test. Okay, so first let me copy the same thing. Now here how to use this decorator, we use right @timer. Okay, now this add function will be, so basically what is happening here guys, so internally it is like this. Let's say we are calling one time, let's say t equal to timer, and inside this we are passing this add function. Okay, so internally it's basically doing this thing only. We are calling this timer function with this add, but instead of this we can write in this way @timer and the execution. Then let me call the function add, let's say 10, 20, 30. So see, time it took 0.00 second. Okay, so basically this is so fast, it's taking 0.00 seconds. So let me introduce a slowness. Okay, so for that what I can do here, I will do time.sleep. Let me give it a delay of 1. See, now timer took 1 second. Okay, because I have given it, so it will be millisecond basically. So this is the delay I have introduced. Now see, the function is taking 1 millisecond to perform its task. So in this way, friend, in production environment also you can log the timer. So for any function you can check how much time it's taking and you can debug the functionality. Okay, this is one real-time use case of a decorator. So this is the real function it's executing, but before the function and after the function, if we want any functionality, we can add this type of logic. So any issue till now here, friend? So if any issue, just let me know in the section. No, right? Okay. Now let's go to the second concept that Somen asks, that how to create a parameterized decorator. Let me create a new file. Parameter decorator.py. Okay. So whenever we are going to use a parameterized decorator, some new concept is going to introduce. Okay. So for that, the first thing you need to know, this is known as decorator factory. Okay, why decorator factory? So basically a factory function is like, you can say, basically it is a factory. Let's say this is a factory. Okay, and this factory is going to produce something. Let's say this is going to produce something. Okay, this can produce multiple things. So this is a factory. So basically factory means it is going to define, or it's going to create some reusable concept or function that we can use later on. Okay, that's why we call this decorator factory. Okay, so for parameterized decorator, what we need? So first point is that it need 3 layers. Why? What I told, this is known as decorator factory. Okay, okay, factory. That means it's going to produce a decorator. It's going to create a decorator. This is the concept. So why 3 layers? See, in simple term, whatever we have done this, right? This is of 2 layer. This is the first layer. This is the second layer. So in the top of that, we will create another layer. okay, for the parameters. So what we will do, it needs 3 layers, and second point you need to know, if a decorator accepts parameter, then it must return a decorator. Okay, so whenever a decorator function accepts a parameter, it must return a decorator. Means, let's say here it's only taking a function, so this is the default way, higher order function. But if you wanted to pass some parameter, let's say a, b, like this, then it should not return this wrapper, it should return a decorator itself. Okay, this is the inner function, it should return the whole decorator. So for that, what we can do is that we can create an upper layer that is going to take only the parameters that is needed by the decorator to perform its task. So let me show you that. So I will create. So before that, any issue till now here, friend? No, right? Okay. So let me create the decorative factory. First, let's create a function. Def add, let's say x comma y, and then we are going to return x plus y. Okay, simple function, right? Addition function. Now what we need is that, so whatever this function will return, okay, whatever this function is going to return, we are going to multiply that with a number. Let's say we will create a decorator, multiply, and here we are going to pass 5. Let's say if this is giving us 10, then 10 into 5 will be 50. Then if we give 2, then 10 into 2 into 20. Okay, so we are going to pass a parameter. So how to create this? So for that, as I told, we need to create a decorator factory. So what will be the logic here, friend? The logic here will be, there will be 3 layers. First layer, second layer, and the third layer. So in the first layer, it should take the arguments, okay, for the decorator, or decorator. What is the second layer? Second layer will take the function, the actual function that needs to execute. And what is the final layer? It should take all the arguments. Okay. So we have already seen these 2 layers, right? For this normal decorator, the first layer is taking the actual function that needs to execute, and the second layer is taking the arguments, okay, all the arguments that needs to pass. So these 2 layers we have already seen, but for parameterized decorator, we need a third layer that is going to take the argument for the decorator. Okay, so what, with that argument we can change the logic. So let's see here. So first, what we will create, the topmost layer, that is, let's say that I will, let's say, give it a multiply, let's say. Okay, so it is going to take the number, which number it's going to multiply. Okay, then what will be the second layer, guys? What do you think? So what should be the second layer? We should define them. Saying function, yeah, function we need to create, but what do you think, what we can create here? So as I told, this is a 3 layer. So first layer is going to take the argument for the decorator. Then in next layer, what we need to create? See, we need to create a function that is going to take function as an argument. Okay, the same concept here, the function as an argument. So let it call it def decorator. Okay, this is going to take function as an argument. And the third layer is the wrapper layer. which is going to take, what it's going to take, it's going to take all the arguments that is needed for the real function, the actual function that will get executed. So for that, star args star kwargs. Okay, so we have created 3 layers, right? Now what will happen? So first we'll do response, and we are going to call the actual function. Here what we are going to do, here we are going to call with that star args and star kwargs. Okay, this is the actual function it's going to call, and it's going to store the in the result. Then what we are going to do, we are going to return this number, like how much number we wanted to multiply with this addition into the result. Now the logic is done here. Next one, what we need to return, we need to return this inner function first, and then we need to return the decorator, because see guys, what we have told is it must return a decorator for the parameterized decorator. So this is the whole decorator concept, but this, the topmost layer, is basically taking the argument for needed in this decorator. So here we need to return the decorator. That's it. Now let me decorate it with multiply, and let's give it a number of 10. Okay, now let me call this add function, print add, let's say give me 2 plus 5. Let me write Python parameterized decorator. See, it's returning 70. So 5 plus 2 is 7. 7 into 10 is 70. So this is the concept of a parameterized decorator. What is the use of decorators? Okay, so why we use decorators? See, I have already told in that video that suppose we wanted to do some specific task before the function and after the function for all the case. Okay, I'll show you. See, here let's say where is this decorator? So suppose 0 says I want some specific task, okay, to perform every time when a function is running, okay, to reuse some functionality. So basically decorator is used to reuse some functionality, and we don't have to write that functionality again and again. Okay, suppose you wanted to print some, you wanted to log something. Okay, so as I told you, let me show you it again here. So here this example, let's say, so here timer C, this add function. So here I wanted to check how much time it's taking. So what I need to do every time, I need to add this logic that I need to first start the timer here, then end the timer here, right, to check how much time it's taking for this function to run. But suppose there are 100 of functions, then we need to write this logic every time, right, before the function gets started and after the function get executed. So instead of that, what decorator will do, decorator will do that same way. Okay, it will use that logic. See, here we are starting the time and here we are ending the time, but in between we are calling the actual function. Okay, so instead of writing every logic again and again, we'll just use this decorator, this timer decorator, for any other function also. We'll just pass this timer. That's it. We don't have to write this logic, start time, end time, then print the time. We don't have to do this every time. So it will take this function, it will call the actual function here, but before that it will start at the logic of the timer. It will start the time, it will end the time, and then it will print that what is the time. Okay, so the main use case of decorator is to reuse the logic. Yes. So do you get it? Is or any confusion here? So if you're not following from the first use, after this video you can check once. But if you still have any doubt, you can ping me in the Discord group. Okay, I will separately connect with you and I will show you. Okay, great. You understand, right? Yes, yes. Great. Perfect. Okay. So many you have asked for this, right? That parameterized decorator. Do you get it? Like how to use the parameterized decorator? Okay, great. Now the next concept is a stacking. Okay. So what is stacking? So stacking means we can use multiple decorator at a time. Okay. Let's say I have one function. Okay. Let's say def get full name. Let's say it will take first name, then last name. Okay. Let me give the full name. Then full name is equal to first name last name. Now here, suppose here I can write multiple decorator. Decorator 1, decorator 2, like this. Okay, I can stack up to n decorators in the top. Okay, this is known as decorator stacking. So how this will work? So here, first let me create this function. Print name is full name. Okay. First let me call this function. Get full name John Doe. If I Python stacking.py, so here we are getting print name is John Doe, right? Now what I want that one decorator to make it in a caps word, in a capital letter, and one decorator will split the name based on the space available. Okay, it will get splitted. So how to do that? So for stacking off, so just one concept let me give you. Suppose if a function have multiple decorators stacked above, it's a decorator 1, it's a decorator 2. So whichever the decorator is nearest to the function, that will get executed first. Then it will move forward. Okay. First D1 will be executed, then D2 will be executed, then if any above that will be executed. So it will move hours from top to bottom. The approach will be top to bottom. Okay. So let's then create it. So first decorator I wanted to create is to change the name to a upper letter. So let's first create a decorator for that. So to create a decorator, so first we need to create a higher order function. Let's say to upper. That will take a function as a parameter. Then what we need to write? We need to write def wrapper. That is the inner function. And what does the inner function will take? The inner function will take all the argument. Okay. Now here we'll write the logic, but before that I need to preserve the metadata, right, of this real function. So from func tools import wraps. So here let me wrap the real function. Okay, now here what is the task here, friend? So here the first task is we will get the output from this result, and then we will convert it to a uppercase letter. So first we will call the function with arguments and keyword arguments. Then this function we will convert this to a uppercase result, right? Then uppercase, so that will do raise dot upper. So here let me print uppercase, then the upper. So here the upper is done. Then we are going to return the result. Okay, and then we need to return this function also. Now what will happen? Whatever this D1 will return, it will go to D2. Okay, whatever the D1, this decorator will return, it will go to D2. So internally what is happening like this? It's basically happening like this. So D2, inside that we are calling D1. Okay, inside that we are calling the actual function. So first this will be executed. Whatever the D1 will return, that is basically the parameter for D2. Okay, that is the case. Now first let's see if this is working or not. So let me decorate it with to upper. Okay, none type object has no attribute upper. Okay, it's telling there is no attribute of upper. So argument is there. So we are calling this. Okay, let me first print the result first. What is coming in the result? Okay, the uppercase is none. So here we are getting a none. Why? Because see here we are just printing, right? We are not returning. So we will return full name. Now it will work. This is upper. The uppercase John Doe. So that means whatever we have given in small letter, it has now changed to uppercase letter. Correct. Now what is the next task, friend? Now I will split this into an array, right? So let's create another decorator. Dev split words. Okay. Here also we'll take a function as a parameter. The same concept, friend. Then we'll create a wrapper function that will take argument, keyword argument. Here we'll write the logic here, friend. So I will call the main function again. Okay, and then we are going with the argument. We need to pass the args and star kwargs 10. So here actually what will happen, this function is now not this get full name. Okay, this is basically this to upper. Now this is basically the function it's involving. If you see here D2, this decorator is taking D1 function, right, as a parameter. So basically whatever the top decorator, it will take the below decorator as a function. So here whatever this to upper function is returning, it will take that only. So here it will take as a uppercase word. Then here we will do repeated word equal to raise dot split. Okay, with a space. Wherever there is a split, we are going to split, and then print splitted words. Okay. then we are going to return it, return the splitted one. Then we are going to return the wrapper, and then we are going to okay, this is not a top class, so this is done. Now what we will do, we will also add this split words. Now see, this is the splitted without taking. So basically it's going to return this, and it's going to return the response, and here we will get the all the splitted words. So now, so let me store it in a result, print the result. Okay, the splitted function is also getting, so because why this is getting a function argument, we are not just calling that, so this is the reason. But yeah, so this is the whole concept. So these two upper, it will go to the split function, and the split function will do the, okay, this is the splitted words. Okay, see, we are getting the splitted John Doe. Okay, so this is how we do a stacking of decorator. So this is the whole concept of decorator, friends. Okay, here we do all type of things like all the reusable code, but let me give you a final example of a real world scenario. So here, this is the use case of a FastAPI. Okay, in FastAPI we use this very often. So basically what is that, let's say we have a option of delete record, let's say. So this is a delete record, and let's say there will be a record ID, for example, let's say, and I will say print record ID is deleted. So what do you think, friend? This delete record, which permissions can all delete record? Can it be any user role can delete it record, or it should be only admin that could delete the record? What do you think? Yes, only the admin can delete the record, right? Because it has some special permission is needed. Not every user type can delete the record. Okay, that means we need to create some decorator. Let's say, then we will have to tell like this require role, and here we need to pass admin. That if user has this admin access, then only they can delete this record. Okay. So for that, let's create a decorator. So def, let's say require role, and here we will give the role. Okay. So which role can delete this? Okay, we have to specifically tell which role can delete. So since C, can you tell me guys what type of decorator is this? Is this a normal decorator or a parameterized decorator? What do you think? Is this a normal decorator or a parameterized decorator? Yes. So this is a parameterized decorator, right? So since it's a parameterized decorator, we need 3 layers. So the topmost layer to accept the argument. Okay. Then the second layer for the decorator. So in the decorator, we are going to take the function, the actual function that will get called, and in the third, we are going to call the wrapper, the innermost function that is going to take the arguments and keyword arguments. Now here, let's say we have one variable that is current user. So this is basically we will get from the logged in, right? Whoever has logged in, that is user. Let's say name is John, and let's say the role is admin. So here we will write our logic. So we will do current role. So from the current user, we are getting the role, and let's say current name equal to current user. We are fetching the name. Then we will check, okay, that if that can be accessible or not, like if this user role is matching with this role or not. Okay, because we are telling here, right, only admin can delete it. So we will check if current role is not equal to role. Okay, if the role is not matching, then here basically I will say print access denied for let's say the current name. Okay, that's it. And then I am returning none. That means we are stopping the execution. And if the role is matching, that means no need to stop the, like, access is granted, then directly call the function. Then let's say print access granted, and here I will call the function, that is the function, and I will pass that args and keywords. Okay, that's it. Now what we'll do, we need to return this wrapper and then return the decorator. Now this is done. Now let's test this. So here required role is admin, and whoever the current user is, his role is also admin. That means he will be, access will be granted and this will be executed. Let's test this. Python real-world.py. Okay, sorry. So I have not called this method. Let me call this delete record with 101. See, access is granted and 101 is deleted. But let's say if the role is let's say user role. Now see, access denied for John. So in this way, friend, in FastAPI we will do role based authentication. If that particular role has the access for that route or not, or to execute that function or not, we will use this decorator concept. Okay, so that's it, friend. This is the whole concept of decorator. I hope it's clear for you now. So just practice it. So 1 or 2 time practice, you will also understand, you will get the flow. But eventually the flow is same. Just maintain these rules, whatever I have told you. Just maintain these rules. That's it. Okay, friends. Any question here? If no, then yeah, we can close this session for today. Okay, no question. Okay, great. If there is no question, if there is no question, yeah, then we can close the session. Hope you have understood it. But yeah, you can go through it once again. If any issue, you can ping me in the Discord. I can show you separately also. Okay, we can connect separately and we can discuss on it. So I will try to share the interview questions regarding decorators in the Discord group. Just check that. Okay. Thank you, friends. Thank you all.